Hey, guess what, people? We are doing Unit 3, Lesson 1. My name is Mr. Bryce. I'm with Susquehanna Valley High School here in Concord, New York. We're doing Common Core Algebra 2, the non-Regents version. The topic of the day is direct variation. If you don't understand what I'm saying, just scan that QR code, and you got the genius that wrote this worksheet. Okay, direct variation. Direct. Go directly to jail. Do not pass go. Do not collect $200. That's what they say in Monopoly, right? So here it is. It's a straight line. Well, all lines are straight. If they weren't straight lines, they'd be called curves. Okay, let's get back on topic here. Direct variation. Direct, and it changes. We began our linear unit by looking at the simplest linear relationships that can exist between two variables, namely a direct variation. We say that two variables are directly related or proportional to one another if the following relationship holds. Okay, proportional, or also known as direct relationship. This is why we call it a proportional, because we have y divided by x equals k. Whew, big mistake. Y divided by x equals k. This is what we know. Y equals kx. Wait a minute. I thought it was y equals mx plus b. Y equals kx for a direct relationship or a proportional relationship. K is the proportion, the constant. Here, y equals kx. No plus. Then it's not a direct relationship. What did I say? Did you hear that? I said no plus or minus. Keep the volume on. Stated succinctly, y will always be a constant multiple of x. That constant multiple can be 1/2, can be 1/3, can be a quarter. K is known as the constant of variation. Here we go. In each of the following, x and y are directly related. Good! We immediately know y equals kx. Solve for the missing value. Okay, why don't we just put down y equals kx, plug in the 15 equals k times 5. Do we now know that if we divide by 5, do we now know that 3 equals k, and it's always going to be the same for this equation? I do. Now, question mark, y equals 3 times 9. 3 times 9. Y equals 27. Okay. Y equals kx. Y equals, -6 equals k times 4. Divide by 4. -1 and 1/2 equals k. Set up the other one. Y equals -1 and 1/2 times -10. Y equals positive 7.5. Where in the world did I get that number? It's still 15. Y equals kx. 12 equals k times 16. Divide by 16. 3/4 equals k. Y equals kx. Y equals 3/4 of 24. Y equals 18. Simple as that. Plug and chug. The distance a person can travel varies directly with the time they have been traveling. Does that make sense? The distance a person travels varies directly with the time they've been traveling, if going at a constant speed. If a phoenix traveled 78 miles, if Phoenix, okay, sorry, not a phoenix, not a bird, okay, if Phoenix traveled 78 miles in 1.5 hours while going at a constant speed. How far will he travel in 2 hours at the same speed? Yeah, says he. Let me see. What am I going to say? Oh, this is boring. Y equals kx. Okay, now, oh, I wonder what constant speed. So that's the constant speed that we don't know. K, constant speed we don't know. 1.5 hours. Remember, x is always independent. Time is always independent. K times 1.5 hours equals 78 miles. Divide by 1.5. Divide by 1.5. 52 miles per hour. Is the rate of change. How fast does it go in 2 hours? Y equals kx. Y equals 52 times 2. Y equals 104 miles. Done. Read the question. Make sure I answered it. Yes. Jenna works a job where her pay varies directly with the number of hours she has worked, like most people, except if you're in salary. In 1 week, she worked 35 hours and made $274.75. You're rich! How many hours would she need to work in order to earn $337.55? Let me see. What am I going to say? Y equals kx. So k, is that a constant or can it change? Number of hours you work can change. So that's the 35. The hourly pay is the constant. And her total was $274.75. Divide both sides by 35, and you get her hourly pay rate. A whopping $7.85. You know that was before this year because that's nowhere near minimum wage. Now, y equals, oh, really? Kx again? So we want $337.55. We know the constant is 785. And we want to know how many hours I have to work. Divide both sides by 785. And I am dividing now. And I get 43 equals x. So 43 hours. No overtime for you. Next page. Exercise 4. Two variables x and y vary directly. When x equals 6, y equals 4. Plot the points shown below. Okay. X is 6. 1, 2, 3, 4, 5, 6. Y is 4. 1, 2, 3, 4. It is already plotted. Okay. Find the values of y for each of the following and plot and connect. I can cheat, but we're not going to cheat. We can say y equals kx. Do we really have to say y equals kx? Why don't we do this instead? Divide both sides by x. Y over x equals k. And that's the slope. Oh, what's the slope? Y over x. 4 over 6. Down 4. 1, 2, 3, 4 over 6. There's the other point. Got it. X is 3. 1, 2, 3. Y is 2. X is negative 6. Keep on doing the slope. You could do 2 over 3 because that's 4 6 simplified. Negative 6. Negative 1, negative 2, negative 3, negative 4. Y equals negative 4. Arg. Y equals 2. There we go. What's the constant variation of this problem? Sorry, already answered it. 4 over 6. What does it represent? It represents the slope. It also represents the rate of change. Wait a minute, I thought the slope was the rate of change. It is! Write the equation of the line of the plotted. y equals kx, y equals 46x. There we go. The relationship often exists between two variables whose values are 0 simultaneously. Direct relationships often exist between two variables whose values are 0. Really? Often? I thought it was always. Always, buddy. Always. The miles driven by a car D varies directly with the number of gallons G of gasoline used. Abigail is able to drive 336 miles on 8 gallons of gasoline in her hybrid vehicle. Calculate the constant variation for the relationship D over G. So this is distance over gallons. 336 miles over 8 gallons. Let me see. Does that make sense? Miles per gallon? Yes, it does. Miles per gallon. Given a linear equation that represents the relationship between D and G, express your answer as the equation solved for D. D equals GX. Now let's see if it really is GX. I'm going to go back over here. I'm just going to say that that is the same as Y. It's not the same as Y, it's the same as K. Sorry about that. So when you cross multiply, product of the means equals product of the extremes, we have 336 miles equals 8 gallons K. So now I see that gallons are really right there. Given a linear relationship equation that represents the relationship between D and G, express your answer as an equation solved for D. There we go. Solved for D. Can we simplify that? Let's find out. First thing that I did was I divided by 336 divided by 8, and it's 42 miles per gallon. How far can Abby drive on 6 gallons gasoline? I wonder. Distance equals 42. Mr. Bryce. That's X. That's X. Okay, now let's change the X. Let's change the X to D equals 42 G. That's why I had to think. Right here. There we go. 252. 252 what? Miles. How many gallons of gas will Abigail need to drive 483? The distance, 483 equals 42 times G, because that's the number of gallons. How many gallons of gas? 483 divided by 42 is 11.5. Great. Hey, if you have any questions, ask. Make sure we do these. Catch you later.